This is the ROS Developers Podcast, episode 113.
The ROS Developers Podcast, the ROS Developers. The ROS Developers Podcast, the ROS Developers.
Hello, ROS developers, and welcome to the ROS Developers Podcast, the podcast that gives you insights from the experts about how to program your robots with ROS. This is Ricardo from the Construct, and today I would like to dedicate this episode to all the people there that are using other robotics frameworks differently than ROS. And they succeed. Okay, so it's not only using ROS, not using ROS, but not using ROS and succeeding. So, ROS already provides you with a fully working robotics framework, as well as a lot of software that already works. So if you go outside ROS, then the robotics world is cold, difficult, and hostile. So if a company is able to succeed in such conditions, then that indicates strength and mastery. So good for you. So if your company is in such situation, then this episode is dedicated to you. Today we are going to learn about such an amazing company that has succeeded worldwide outside of the ROS world. But we will learn how they did it, why they don't use ROS, and what do they use instead. But we will also learn about the process to get robotics engineers in their team. So this episode can be very interesting for you if you are looking for a job also. But before going into the meat, let me tell you that in case that you still believe ROS is the good path to follow, you can learn about ROS 2 and ROS 1 also at the Construct. We provide self-learning based on robot simulations and remote real robots. So you will follow our lessons using your web browser and practice from the minute one with the simulated robots. Also, as you advance the lesson, you will practice with the real robots located in Barcelona, so you will connect remotely. They are available 24/7 for you to remotely connect to them and do your practice. Have a look at the webpage. I will put a link here below on the show notes, and you will see the different subjects that you can learn about ROS 1 and ROS 2. And having said all that, let's go to the meat of this episode. Let me introduce you Denis Kanunikov and Sam Thornton. Denis and Sam work at Mujin, a robotics company that, we are going to learn about it in a minute. Then for the moment, let me tell you that Denis is the lead robotics system engineer of Mujin, and Sam is the manager of talent acquisition. Welcome to the podcast, Denis and Sam.
Thank you. It's nice to meet all of you guys, and I hope you're going to be interested in it.
Yes, of course, they are going to be interested. Pay attention, guys. This is good stuff. It's coming. And then the first question that I would like to ask you is, what does Mujin do?
So Mujin is a company. What we are doing is we are focusing on the development of the software for industrial robots. And our final goal, which we are achieving, is to make a robotics platform where you can use your industrial robots, connected to Mujin controllers, and then execute different tasks in your factories, in your production line, and so on.
For example, if there is we are talking about robotic arms.
We're mostly talking about industrial robotic arms, but it's not limited only to them, because Mujin provides the solution not only to move your robot arm, but its entire infrastructure, which can be designed and working together with Mujin controllers. So Mujin controllers is not only moving arms, it's also can control vision sensors, 3D sensors, 2D cameras, laser sensors, grippers, and so on and so on. As well, we can control mobile robots to make entire infrastructure for industrial robots to work. Because if you want to automate your line, right, your production, you can't just buy a robot and say, "Oh, great, now do your job."
Yeah.
It's not going to be happening.
Yeah.
Industrial robots requires a lot of infrastructure to be involved to make something really productive. Otherwise, you're going to be investing too much, and then you won't reach your expectations.
Yeah, so you will not have a practical application working for your purposes, right?
Right, right.
Okay.
With Mujin, with Mujin controllers, what you can do is you can set up your system very fast and easy, and then just have your application work as soon as it is provided by our company.
Okay, and why did you decide to attack this problem? So there are a lot of problems in robotics that can be solved. So what is specific about the...
Yeah, that's true. There are a huge amount of problems in the robotics. But you can think about all these mobile robots navigation problems, about housekeeping or house assistant robots. But what we think first is that who gonna make these robots? Who gonna make everything to our world, right? And we found that industry is the one which is struggling about a lot of different tasks. And especially right now, they're struggling of labor shortage. For example, you can't keep increasing number of people right in your facility because you need a bigger facility, and then you need to move, and then grow, then open more and more facilities. And hiring people becomes a problem actually right now. Nobody wants to do a repetitive, hard labor job nowadays because it's really hard. And if you think about all these industrial facilities, usually they're not that friendly to people. Yeah, that's why we think about, what can we do for this? Why robots are not that widely used in these industries? And then we see that the tasks which they're doing are pretty complicated for original original approach of industrial robots, which is called teaching.
Okay.
Where you do teaching of the robots.
What does this consist of?
So teaching consists of actually saving points and making robots go through these points and just move. And then after moving to one point, execute something. Like open gripper, then move down, close the gripper, go up, and so on.
That was a requirement for the robot before, let's say, before Mujin provides the solution. So this is like a requirement for any industrial application that needs to move stuff from one position to another. So you have to get the robot and then teach them how to grasp the stuff and then put it on the other side, right? And which movement.
Yes, that's correct. Exactly that. And if you think about a variety of tasks, a lot of tasks in the industry can be done by this, but not enough.
Okay.
It's not enough to achieve the automation of the warehouse, for example, right? And because you can think about different varieties of items you have to pick up in one facility, especially if you go to logistics business. All these warehouses, they operate with 100,000 of items, of different items. And if you're gonna teach the robot to handling each of them individually, you're gonna waste your life. Yeah, you're gonna be doing this forever.
And also those things, they are changing maybe from week to week. Also,
that's right. You can think about, I don't know, Black Friday sale. Some customer sends you a new package with one additional item inside. The size changes, the trajectory which you taught the robot before is not available anymore because it's gonna collide with a container, I don't know.
Exactly.
And that's it. And this teaching process actually requires a lot of knowledge from the robotics engineer and it's time consuming, so you cannot make it faster. Actually, there is a limit how fast you can do it, because you need to input particular number of commands in particular ways. So it's limited. So if you want to deploy, let's say, 20 robots, you need to program each of them. Yes, you can copy the programs, but usually each of the robot positions slightly different.
Exactly.
And then what appears that they have to spend time on verifying, checking, and validating each of the programs for each of the robot. And this is very time consuming. And you know, robotics engineers are pretty expensive. So yeah, this is what it is happening. And with our solution, we call it a teachless solution, where you don't need to teach the robot. What you do, you set up our system, you set up parameters, you choose kind of application you want to do, and everything else is done by Mujin. So we do take care of the robots control, we take care of dynamics of the kinematics of the robots, we take care of the changing environment. For example, if there is a 3D sensors, right, we can use them, and if something changes, we know about it, and we can adapt our motions based on this.
Okay.
Actually, we do compute the motions in real time based on the current environment.
Situation.
And
of the
on the current
environment,
situation,
So, yeah, so it's perceiving the current situation, and based on that, so it's not a pre-programmed path like in the teaching situation, right?
That's correct, yeah.
So it's
Even though we have a solutions with extended, we call it extended teaching approaches, because there are still a demand like this in the factories, especially for some particular machines which doesn't change that much. And then with the robot arms, because like it's about operating like some chemicals, for example, inside of machine it usually doesn't change, but you still need to move it, and very carefully. The amount of liquid can change though, but still our system can handle it.
okay. But then your solution includes the robots themselves, or
So our main product is a MujinController.
MujinController.
So, which is originally was designed to control industrial robots. So you connect industrial robot to it, and it become intelligent robots.
Okay, so you have your product is MujinController,
Right.
and then this can be bought by any other one factory that already has their robots there, that they have they bought the robots maybe several years ago.
Yeah.
So they buy your MujinController, and then they can add these skills to their old robots.
That's correct. Yeah, that's possible. We actually got an example in our history about powering like robot from 70s. So we connect MujinController to control motors directly of that robot, and it was working. So we made it work, and people are happy because now they can change the programs, not even programs, they change the parts much simpler. They just upload the new 3D data of the part, and then Mujin gonna follow the required path.
Oh, okay.
It was actually about laser cutting.
Oh, okay.
And before, there was a guy who was doing this by hands, actually. Why they decided to change it is because the guy retired, actually.
Okay, and nobody else wanted to pick his place.
Yes, because it's
But
really
then
challenging.
what you're usually selling is this solution, the MujinController only, and then the people they manage themselves, or how?
Not
what is-
exactly. There are multiple ways of working with Mujin. One of the ways is, you just buy a MujinController and try by yourself. You got a manual from us. You study at Mujin office probably for several weeks. We have trainings. We can set up trainings for this, but usually for the industry it's not enough, because they really need a final solution. And Mujin as a company, what we are doing, we're providing the entire solution. It includes MujinController with robots. It could be some third-party robot. we actually don't really care what kind of robot maker is going to be, or it's going to be a custom-made robot, as soon as we can have a communication protocol with it. Plus, we add our vision systems with sensors, 3D sensors, 2D sensors based on the needs. As well, we take part or we design grippers, or you can just use one of our standard grippers which we provide.
That already exist in the market.
Which already exists in the market, yes. We provide protocols for communication with warehouse management systems, for example, with PLC. But at this stage, usually we need to understand already what is this project about, what you want to automate. And because we have quite enough expertise, we can even give you better solutions which you are thinking about. And to set up entire flow, because that's the problem. A lot of people in industry, they don't understand how to include robots into their flow.
Yes.
That's why, as an experts in industrial robotics, we can give good suggestions. Because, as I said, robot is not just a robot arm. It requires infrastructure around. And to do this, we're here to help you. You just send us a request for the consultation. If you have a project in mind, we can help you.
Okay. Yeah. So then it's like what you show me downstairs, Sam. This area where you are doing this those demos. I mean, not demos. Sorry, is testing of this final solution that you are providing to your customers, right?
Yeah, and it's one of the rare things I think about Mujin that differentiates us from a lot of other robotics companies out there is that we have these established processes around how to actually prepare a solution for a production customer site. We are able to, on site in our facility, prepare a simulated version of what the final solution will look like for the customer, actually do a POC, show it to them, prepare it here before we ship it out to them. We have the largest facility for doing this type of robotics development in Tokyo, and that's why, right? It's that what Dennis was talking about, that we need to develop this know-how in order to consult effectively about what the customer's real solution ultimately should look like, and
let me clarify a couple of things. So we are now here in Tokyo, in the Mujin facilities of Tokyo, awesome facilities, and you mentioned about your simulation of the final product that your customer will get, the final solution. But just to clarify to the audience that when you say simulation, you don't mean software simulation. Right.
So we do that as well. We do a lot of software simulation as well. But no, we're talking about a 14,000 square meter facility full of industrial robots that we're really testing actual scenarios on.
Exactly. So just to clarify the whole solution. Okay. So the people understand and get a picture in their mind. So you have this MujinController, which is your main product, let's say, but usually your customers, they want a full solution. I mean, it's a set of robots that can do this. That's what they want. So that's the final product. Then, in that case, you not only sell the MujinController, but also the whole solution. So you engineer this solution with this robot arm from this company because it's needed for that. With this other robot arm, you may use also some grippers from third parties or the ones that you have developed, and you may use other 3D sensors that you have developed also, or maybe from somebody else. You actually, at the end, you don't care because you can talk to all those systems as long as they have an API or a protocol for communication. And then you design here that solution, and then you build that solution in your facilities at scale, and then you can test if everything is going to work. And then once everything is done, then you can pack it and send it to the customer and open it there and just adjust the things that are different from your facilities to their facility.
That's almost there. Yeah, it's almost correct. There is always definitely differences between the projects and the setups.
Yeah.
Could happen. We cannot always test on entire scale, right? But yeah, that's what we do. But as well, we actually don't make our hardware by ourselves usually. Maybe some particular gripper models, yes, but we don't make robots. We don't make sensors by ourselves. There are a lot of good manufacturers who can do this better, because in the end, what makes sense is that it works and it works well.
Yes.
So we decided that we're going to be focusing on the software to make the application work
Yeah.
with what we have right now.
Yeah. The whole thing, right?
Yes.
Like it's like let's say in an orchestra, right? So we
Right.
have the violin and the flute and so on, but then there has to be a coordinator that makes everything and then generates the final musical piece, right?
Yes.
So it's, okay.
That's correct.
Okay, great. Let me check my questions, because we have been talking without following, so I don't know. So I don't know which ones I have checked, and this is normal. Okay, so
No problem.
this is not going to be cut in the podcast. This is it's like this. This podcast is like this. So So let me see. So yeah. So in this process, so you are engineering how everything has to work. So this is something that you design. So you say, oh, we'll put this robot here for the solution that the customer wants. You need to have this robot here, and then this conveyor belt here, and this autonomous mobile robot that comes here with a pallet or something, whatever. So this is something that you and your engineers you develop, right?
Yeah, we also take parts in this design of the facilities. Usually it's our system integrators, like our partners, who is doing this as well. Because, for example, we don't do a lot of hardware, right? Mm-hmm. We don't do hardware. We don't do all these ASRS systems. We don't, and that's why we usually go to the customer through some system integration company.
Okay.
But because we are experts, we usually take part and talk directly to the customer with system integrators, because we know what the system can be achieved, what kind of system can be achieved, and what value the robot can provide to the end user, and how to achieve this. And actually, in the end, it's all about to make it automatic, right? So in the end, it's us who is doing the job of robot motion and of executing the application. And everything else, as we discussed, it's infrastructure to make it happen.
Okay. But then what happens if something needs to be changed? Like, for example, I don't know, the customer, he is changing his mind now because, I don't know, there is a pandemic or something that needs to change his business in another direction. So what happens with those robots?
So, not sure if I understand fully.
Yeah. So if they need to change their product, their way of using the robots, because the products that they have to manufacture or to ship or whatever, their functionality has changed. So how do they change? Can they change that by themselves? Somebody at the company, your customer's company, has received already all the robots. They are all there in their facilities. They are running, but now something changed in their business, and now instead of bottles, they have to do, I don't know, sackets like this. So what do they do?
First, most likely they consult the system integrators and us. But actually, if it is just a product change, it's not a deal. It's not a big deal. We just need to think about if the current setup is usable for that particular part which they want to pick up new. If yes, then nothing to be changed.
Okay.
If no, then we can think about having a different grippers. If they want to support old and new ones, we also have a systems which we call with the tool changing mechanisms, automatic tool changing. So we, as a robotics platform, we can actually decide and recognize when we should use particular tool for particular item, for example. So as you said, if it is a bottle versus a box,
for example,
most likely you won't be able to pick up a box, like 30 kilogram box, with the same gripper as the bottle. So most likely you will need two different grippers, but as soon as you can tell us, or we can scan and figure out what it is, we can decide which tool to use, right?
Okay. Okay.
And that's it.
Yeah.
Actually.
I'm asking you this question because I wanted to clarify
Yeah.
if once the product is in the customer side, if it's so if they need some work from your side in order to change their configuration.
I see.
So I wanted to clarify, because so that would be also a very cool thing if they could do it, but that's a difficult thing, it's a difficult thing. Sorry, I mean by people who are not experts. So the owner of the company, that he doesn't care about robotics. He's just an expert in water bottles. He's just an expert of that. So and his workers also, they don't know about robotics. But I wanted to understand if there was a way for those people who are unskilled, if they were able to modify the setup.
Okay, so first of all, it depends on what kind of applications they bought from Mujin, because we also sell in kind of different applications. Yeah, you won't be able to change, for example, from divanning system into palletizing system directly.
Okay.
It's kind of different configuration of the hardware even. So that's most likely, there is no way you need to go through Mujin and SIRs.
Okay.
But if it is something simple, yes, you can adjust parameters by yourself. We have manuals. They can read and set it up. For the parts with tool changing and different products, if it is not originally set up for this, they would need some consultation from us, as most likely tool changing will require additional hardware again, right? But if it is already set up, then they just specify, this bottle, I want this tool. That's it.
Okay. That's what I wanted to
That's
understand.
what they can do, yes. But for the hardware changes, yes, they will need to consult and request system integration or Mujin for help.
Okay.
There's probably, I think, maybe three major buckets, and you can correct me if I'm wrong, but I think there are things that the customer can change by themselves, right? If it's just a matter of taking a slightly different object, like imagine an e-commerce application, you were picking saran wrap, and now you're picking plastic bags in a box that's a slightly different shape, right? This is probably something the customer will be able to do.
Okay.
Then there's another bucket of things that the system integrator will need to support. And then finally, there's a bucket of things that it's at a level where Mujin will need to come in and support the development of that particular solution.
Okay.
But it's one of the big differences between Mujin and the traditional industrial robotic system is that there are these buckets of things that can be solved by the customer directly, whereas traditionally you needed to call in the proprietary robot teaching specialist every time that there was even a minor change to your production line.
Okay, now it's clear. Sorry, I wasn't able to express my question, but now between you two answer, I think that we got the proper answer, even if the question was not the proper question. So, okay. So you mentioned before that the MujinController, they can work with any robotic arm. So how do you talk to each robot proprietary API? So the API because the robot manufacturer provides you the documentation, but then that means that your MujinController has to be adapted to each one of those, isn't it?
Yes, that's correct. We need to be able to talk to each of the robot controllers based on their specifications and based on their protocols. Most of the robots support pretty much simple protocol. What we need to have is a real-time control mode to be enabled. Usually, actually, it requires additional hardware or software from robot makers, if it is through the robot makers, because I think it's just because it's their business way of monetizing as well. But if it is just a custom-made robot, as soon as you follow some standards protocols, we can share, we can explain. It's pretty simple. What it does is just send the point actually in particular time,
Yeah.
right? In particular frequency,
Frequency,
and
exactly.
that's it.
then you
That's
get-
actually what we do with also robot makers. We do this, but through the robot controller of the robot maker. It's actually connected with a cable, and then we just send commands. We start our program on top of them. In them, there is ways usually. It's very simple. It's just listening to points and then executing them. And then that's how we do control.
Yeah, but I'm asking you this question for one reason.
Yeah.
Is that the reason is that okay, so each one of those robots is from his father and from his mother, so they speak in different, even if the protocol is simple, but it's a different protocol.
Yeah.
And then you have to adapt all this. Something that you have to create this let's say driver.
Yes,
you can
correct.
call a driver for that allows your MujinController to talk to them.
That's correct. Yes, this is kind of a driver, which on the low level of the
Yeah, on the
communication,
low level,
actually.
exactly.
All the logic about how to pick, what to pick,
Yes.
how to move the arm, what is the velocity, acceleration, trajectory, it's all independent.
Yeah.
What is just is this like low level driver.
Exactly.
Yes,
exactly.
we do support most of the robot manufacturers in the world right now. And,
Because you have been, sorry to interrupt, because you have been already working with many of the manufacturers, so you kind of have a library of drivers for different, right?
as well as the robot models. So, you know, whenever the new robot models released, we need to gather 3D data. If somebody like got their system 2 years ago from Mujin, and some robot released this year, yeah, we will need to upload the new data to them. But that's kind of it. That's it. The protocol usually doesn't change that much, so the protocol is usually the same. So yeah, we do support multiple robot manufacturers. Most of the famous ones in the world, you most likely know all of them. And if there is something new, if there is some robot maker who wants to adapt to use Mujin with their system, there is no problem. We can easily add it, such a support.
Okay, and but that's the point of my question is because what you already know where I am going to is that if you use ROS, then you would not require to be creating those drivers, because the robots, they would talk ROS, so your MujinController talks to any robot that talks ROS, so you can skip this step of creating the drivers because that will be implemented by ROS. So, but you are not using ROS. That's the main point of this interview. So why not using ROS if that can save you in this case? So can you tell us? The audience is very interested for that question.
So first of all, I would say that creating a driver is not such a big deal. You do it once for one robot maker and that's it. So there is a reasons why we don't use ROS, and there are pros and cons of using ROS, as you know, and I think your auditory also knows this very well. There are multiple versions of ROS, ROS 1, ROS 2, ROS Industrial. Actually, our CTO, Rosen Yankov, was part of the Willow Garage, who was developing ROS as well, and we're not using it. ROS, because what we noticed that there are issues like which can be happening during the integration of the systems, and we need to take entire maintenance of the entire software pipeline which we deploy. With the ROS it becomes very difficult because we are not maintainers, we don't own ROS, right? That becomes a little bit tricky. As well, there are, I think there are some efficiency problems, as I heard in ROS. But our systems has very high frequencies of talking to the industrial robots, of controlling trajectories. We can be delayed by 2 milliseconds at any point of time. And the requirements are very challenging. I think ROS is very good about setting up entire system to do some research, to do a lot of communications with different hardware, software. But what we are doing actually is usually this amount of hardware which we talk to, it's not like infinite, right? Every time, as you said, yes, we need to add drivers to support it, but we're also very picky about which hardware to use, because it should work for 10, 20 years without replacement, without any failures. So it's not that critical for us. So most critical is the performance, and that's what, as far as I know, there are some troubles and issues in ROS.
In ROS, even in ROS 2, right? Even in ROS 2.
But it's more about that we cannot control where it goes, what is the direction, unless, and then if we're gonna just branch out, what we're gonna be developing our proprietary library.
Again, yeah.
So what's the difference?
I see your point. Okay. Interesting point of view that I was very, very interested to know and to provide to the audience, so the audience can decide by themselves. So we are about ROS and so on because we like ROS very much, but of course it depends on the personal situation of each one of the companies and engineers that are using. So we wanted to provide your point of view about ROS in that sense, because it can clarify some people ideas.
That's correct. Companies. That's correct. You should use proper tools for proper tasks.
Exactly.
Right. That's what we're about. So it's not that there are something good, something bad. There are different stuff for different situations and applications. Yeah.
Okay. Then, so I had the question about what do you use instead of ROS, but if I have understood, you don't have any, let's say, any established framework with all the letters, the framework. What you have is a set of drivers that talk to the different robots, and then once you have this, you have all the data imported into your MujinController, and then
you can think about MujinController as a framework.
As a framework.
You can buy it, and you can use all the APIs provided by Mujin, all the possible communications like via PLC, via WCS, FTP, whatever. There are multiple protocols with multiple ways. There are even just direct communications through our clients, which are actually publicly available. MujinController clients, they're available on GitHub.
Those clients are for external applications to talk to the MujinControllers.
Yes, you can do. You can even run most of the tasks through that applications.
Okay. I know several universities, for example, that they bought big robotic arms at that time for doing experiments with and teaching the students and so on. So that would be a possibility, right? So they can buy the MujinController and then control by using your software algorithms that you have in the inside, so they can apply this to their already existing robot, right? And then create, for example, like a web application that talks to that MujinController, so they can show on a website.
That's actually possible. We don't have such use cases yet. But I see no big troubles to do this.
Okay.
Except that if it's not going to be in the industry, it takes a lot of time to support, and we need to be careful about what you're going to be doing. But there is open APIs which you can definitely perform through MujinController, and it just works.
Okay. I'm just launching ideas, so we are here to let the audience know, to learn about this. So that was just an idea that popped in my mind by your explanations. Okay, just launching there. Let's see. Then we have another thing that. So I have read through your webpage that you mentioned something that is called a QuickBot solution. So with this name, what is this attached?
Okay, so this is a product from Mujin which is available in the USA. So this is a depolletizing solution, which plug and play solution actually. I think you can read more about it on their website or request Mujin USA about it.
Okay.
So the idea is that it can be used as a service robot. So somebody needs it, we plug in and play, install it within 1 day, and then when they don't want to use it, we take it out. So it's entire hardware setup with software setup all together, ready to be shipped.
Okay, that's interesting, because I participated on my previous life. I was working for another company, robotics company, and then within that company we were participating on a European research project, which was about providing something similar like this, as like a robot as a service application for industrial applications. So, and then the idea was to create this, and in my opinion, it didn't end very well because those research projects.
I mean, you have to be very careful what you deliver and what is the demand. That's why it takes so much time actually to start and work in industrial world. The level of the accuracy and error rate should be super small, accuracy super high. We're talking not about 1% of error rate, we're talking about 0.0001%. So you can fail only maybe once in 1,000 orders or picks, for example. So the entry is very high, and as well you need to understand what the customer really needs. That's why we go through these iterative approaches where we deploy to the customer, adjust the systems, then we learn lessons, they learn as well how to use our system. In the next iteration of the warehouse, we improve our systems, increase efficiency, performance, and so on. But without initial installation, we won't even know what is the real problems. Because whatever you think in the laboratory and whatever happens in the reality, there is some gap which has to be filled. And that's the difference between research and industry.
Okay. You want to clarify that what I meant is that I think that the idea is good. So I think that the idea of the project is good. What I was criticizing in my comment is not the idea, is the let's say the research project, how it is handled in that particular research project, that I was in. So not very focused on results.
But I think it's actually very complicated to have such a system to be fast installed and working.
Yeah.
And in factory automation, you said, right? In factories, production lines where you do like assembling or something like that, it's extremely difficult.
Yeah, I can imagine. I can imagine. And I have one question, so that I wanted to leave for the end, but let me ask you now that you mentioned about the automation in how to automatize, automation, right? And so about the case of Tesla. So if maybe you are aware that Tesla tried to automatize the whole factory. So no people was required there, but then at the end they have to go back and then add some people at some stages. So can you explain us why it could have failed? Do you have any idea, any opinion?
I'm not a Tesla guy.
Yeah. But as
so
an expert
I couldn't tell you. I couldn't give you much comments why they failed or what's wrong.
Your opinion as an expert, if
it's very challenging. It's very challenging to automate warehouses.
Full warehouses.
Mujin has some examples of full automatic warehouses. Actually, I believe in 2018 we have JD.com. The factory in China, which was full automated with the Mujin robots. but it includes not only Mujin robots. That's the purpose. You cannot do it only with your hardware. At least I don't see how it can happen right now. At least we cannot do it. So it requires a lot of, as I said, infrastructure around, a lot of setups, maybe even change of the processes, which were originally designed for humans. They are not good for robots, right? And all this entire set of problems, plus set of problems from the technology perspective, also huge. We actually right now, Mujin has solutions actually, I think, for each stage of logistics warehouse management, for each stage.
Okay.
But to make it all together, it still takes time, because it will require bigger solutions, like also taking care of the management systems, also thinking about all these conveyor belts and so on and so on. We can have like palletizing solutions, depalletizing solutions. We can have even piece picking solutions, right? Devanning solutions or truck loading solutions. But to put it all together, it's it's first of all big risks for a business, because to make entire warehouse automatic, if it's not going to work, and the entire warehouse designed for robots, most likely you won't be able to put people much inside as well. So it's gonna happen. Don't worry.
Yes,
We're gonna reach to that level.
Yes.
We're approaching to it, and I would say that as soon as we can do it, I could say, oh, my mission is accomplished.
Okay. Okay, nice. Nice, very good. Then now I would like to ask you about your company, because so I have been hearing about your company a lot, and then how you have been growing, and then so my question would be now for Sam is, so are you still growing and looking for engineers and developers?
Yeah, I mean, always, and I think we will continue to be growing and looking for engineers for the foreseeable future. We're not slowing down soon. So yeah, I mean, we have a number of different areas that we're hiring engineers from all around the world. We are based here in Japan, in Tokyo.
So the job will be here? Will be here?
Yeah, but we're actually an English first engineering environment internally. So obviously, I'm not Japanese. Dennis is not. We do have many Japanese employees as well. Of course, on the business side is very Japanese as well, facing with Japanese customers, right? But
also, your CEO is a
Japanese to work here. That's right, and Issei, our CEO here, is Japanese. But I mean, we're hiring engineers across all different segments. I think, Dennis has probably touched on a lot of the different layers of it today, but, we do everything from starting at the low end, from the planning of the controller itself, the design of what's basically this industrial computer that we produce, to the embedded systems that are in it, to the backend system, the APIs. We even have a kind of a tweaking of the Linux kernel that goes on, and some other fun things in the backend, to the robotics control system and control algorithms that Dennis and his team work on. We have a vision team that works on all the 3D vision and the modeling that comes out of that. We have a team building simulation software for robots, and we have a front-end team as well, because we have our own UI that the operators interact with when they actually control the robots. So.
It's a web interface?
Yeah, it's like a web interface, basically. I think Dennis can maybe talk a bit more about it than I can, but in depth. But basically, yeah, I mean, we have, we're building in JavaScript. Our backend team is building in Go as well. C++, Python skills all over the place, of course, on the embedded side and the robotics control and vision side as well. But yeah, I mean, there's a web systems element to what we do as well.
And then, so what is the process that you follow to enroll the engineers, and which kind of do they need some specific skills or diploma, or so what can you tell to the audience about that?
Yeah, I mean, I can say that Mujin is a hard place to get a job. We're hiring a lot, but our talent bar is very high. We're selective. Our founder, CTO, ROS, is a Carnegie Mellon PhD, there's a lot of people with PhDs here from top schools, MIT, Tokyo University, a top school here in Japan, a lot of graduates from their top robotics lab. So yeah, I mean, we have quite high expectations for people. You know, in terms of skills, we're really, you know, Mujin is optimized around solving real world problems now. So we are, you know, we're looking for people who are able to, you know, do real hands-on development work. You know, we're not writing research papers and you know, presenting at conferences. We're delivering robots to, you know, industrial work sites. So we're really looking for people who can program, especially, you know, C++ for like a team like Dennis's team. C++ skills are great. Python skills are great. That makes up a lot of what we do. But it does depend a lot on what team we're talking about.
Yeah.
If you're a front-end developer, then of course, you know, if you have TypeScript skills, that's more relevant. So,
Okay, so if there is any way that the audience, that are people in the audience that is interested, maybe how to apply to those jobs. So do you have a place that I can direct them?
Yeah.
Maybe I put a link or something?
Yeah, of course. Yeah. We have a jobs page. It's overflowing with all the different places that we're trying to hire people into all the time. So please, we encourage everyone who's, you know, doing development, who's passionate about robotics, who wants to work on software for robotics that are, you know, going to production. Please check out our job site. There's it's broken down by team. You can probably find the place that fits you best. And after that, there's going to be a series of interviews and tasks, and basically you'll speak to someone from my team. You'll speak to someone like Dennis, who, you know, is managing the real process, and he'll ask you some tough questions about, you know, for example, the robotics control algorithms. Like, do you really know your stuff? He'll check you out, and if you can pass him, then you know, we'll have a task for you, some kind of a homework to take home, and if that looks good, then yeah, you're pretty close. We'll get together and talk about it.
And all this process is made online, or they have to come here?
Yeah, so we're bringing people here from all over the world. Our development team has people from over 25 different countries in it currently.
Yeah, but I mean during the process.
During the process, yeah. So we're built for hiring from overseas. So you don't have to come here to get through the process, especially right with everything that happened the last couple of years. A lot of virtual is how the process will happen at first, and then of course we'll help you come over to Japan and get settled here if all goes well. So hopefully that's where we'll be soon. Some of your audience. Okay,
yes, people on the audience that you are there. So this is a direct call for all of you. One final question. So it's internship an option at Mujin? Are you accepting interns?
Mm-hmm. Yeah, so we do accept interns. You know, of course, space is limited. You know, we always wish that we had more capacity to bring on more and more interns, but we have to be picky because, you know, it takes Dennis's time for him to help the interns learn, but we love to bring people here from universities all around the world and help them to get the real world hands-on experience doing robotics like this. I think it's a rare place where you can get that experience in an internship. So yeah, we try to encourage that. And if I could just add,
sure,
know, just my advice for anybody out there who's you know, looking to get into, you know, real software development for robots as a career, you know, my advice would be go deeper into the development work, and don't just stop at the level of you know, importing a library and putting some function calls together and getting it to work pretty well. I would say really look at what is the library doing, what is actually under it, because basically at a company like Mujin, we're developing the libraries, right? Yeah. So it's a great starting point to have ROS, to have OpenCV, to pipeline your vision data into your control algorithm and say, cool, you know, wow, it did it. It really, like, you know, my robot, you know, moved this ball across the table. That's awesome. That's a great entry point, but you have to go deeper than that. If you want to be a vision engineer, you have to think about 60 object pose estimation. How does that really work?
Wow.
What's going on with stereo cameras, right? You have to go to that level of depth if you want to be able to develop and handle all of the real world edge cases.
Okay, yeah, that's a very good point, and also it's a very good punch into our ROS world. So I feel the punch here. Yeah. Very good advice. Very good advice. So people that you are listening here, you know, so you have a roadmap now in front of you. Then one final question. Okay, that's the final one. I promise. So, what are your secret plans for the future? Can you tell us about what to expect from Mujin in the next years?
More robots to be deployed, definitely.
Yes.
So what we're going for is to deploy more complicated applications from whatever we already have, and definitely expanding more in the world. We have countries where we are not presented with our projects yet, and we want to deploy more robots to make people life easier. Actually, that's our main vision, is actually to liberate humans from hard labor jobs. And we are going forward it, so we're going to be, most likely in a couple of years, we're going to be presented in more countries than right now. We are planning to open more offices. Finally, the COVID is much easier to go with business right now. So yeah, we're going to grow in the scale as well, in not only number of offices, but also number of applications. But you can track our progress on our webpage, on our blog, on our news page.
Okay, yes, I will put a link to all those places that you mentioned on the show notes of the program. And okay, so maybe in a few years, Mujin next to your home is there, so you can find it next to your home. So I wish you the best of luck and that you achieve this vision that you have in the next years. And thank you very much for being on the podcast.
Thank you for being with us. It's really interesting to share knowledge, and thank you for such a good questions.
Thank you very much.
Thank you, Ricardo.
Thank you, Sam. And that is all for today, audience there. Thank you very much for being here, and see you the next week with a new lesson from the experts. And until then, keep pushing your ROS learning.